The most incredible thing about our universe has got to be its size. It's just mind-boggling. But here's the catch. That same vastness is also what makes it so incredibly frustrating. We can find new Earth-like planets and other galaxies, but the idea of ever actually getting there, it feels like pure science fiction. So let's dive into that cosmic problem. Okay, so let's take our closest galactic neighbor, Andromeda. If we jumped into one of our spacecraft right now, one that's zipping along at about 28,000 kilometers per hour, how long do you think it would take to get there? 94.5 billion years. I mean, to put that into perspective, the universe itself is only about 13.8 billion years old. So, yeah. Okay, but what if we could travel at the speed of light? The absolute cosmic speed limit, right? Even then, the trip would still take 2.5 million years. It's just staggering. It really makes you wonder, what's the point of finding all these amazing new worlds if we can't ever hope to visit them? And that leads us to a really big question, maybe the big question. Are we trapped here? I mean, are we just stuck in the Milky Way forever? Well, what if there was a shortcut? So yeah, this whole problem of just insane distances, it's the biggest wall standing between us and exploring the universe. But for decades, sci-fi, and more actual science, has been teasing us with this wild, almost magical solution. I'm sure a lot of you have seen the movie Interstellar, right? Where the crew just zips over to a whole different galaxy in what seems like minutes. They do it by flying through this mysterious sphere they find out near Saturn. And that cosmic gateway? Yep, it's a wormhole. But here's the really cool part. This whole idea of a wormhole, it isn't just some Hollywood invention. No way. It's actually an idea that's deeply rooted in some of the most profound, most established science we have. And we have one of the greatest minds in history to thank for it. To really get it, we've got to jump in our time machine and go all the way back to 1915. We're talking about Albert Einstein and his absolutely game-changing general theory of relativity, which he laid out in what are now called the Einstein field equations. Okay, so here's a mind-bending part. Einstein basically said that space and time aren't just this empty stage where things happen. Nope, they're woven together into this one single fabric he called space-time. And big, heavy things like planets and stars, they actually bend and warp this fabric. Just imagine putting a bowling ball on a giant trampoline. See how it creates that dip? That dip, my friends, is gravity. Right, so these equations are, well, they're incredibly complex. They literally describe the structure of our universe. But just like any equation, they have solutions. And when other scientists started digging into the math and solving them, they found some absolutely wild possibilities hiding in there. Remember back in school when you had a simple quadratic equation? One of those could have more than one right answer. Well, Einstein's equations are like that, but on a cosmic scale. They are way more complex, and they also have multiple totally valid solutions. One of those solutions pointed to black holes, an idea so strange it took us 100 years to actually take a picture of one. And another solution? It predicted wormholes. So back in 1935, Einstein got together with his colleague Nathan Rosen. They were working on one of these solutions and came up with this idea they called an Einstein-Rosen bridge. We know it by a much catchier name today, a wormhole. And what is it? In theory, it's a tunnel, a literal shortcut through the fabric of space-time itself. Okay, so how on earth would a shortcut through the fabric of reality even work? It's a tricky concept, for sure, especially since we're stuck perceiving things in 3 dimensions. But there's a really simple analogy that makes it all click. Okay, here it is, the classic paper analogy. Imagine our whole universe is just a flat sheet of paper. Now, to get from point A to point B, you have to crawl all the way across the surface, right? That's the long way. But what if you could bend that paper? What if you could bend space-time through a higher 4th dimension we can't see? All of a sudden, point A and point B are right next to each other. Now, if you could just punch a hole straight through, you've created a tunnel, a path that is way shorter than going the long way around. And that tunnel is the wormhole. And the name wormhole, it's perfect, right? It actually came from a physicist named John Wheeler back in 1957. He pictured a worm on an apple. I mean, instead of crawling all the way around the outside, the smart worm just burrows straight through the core to get to the other side. It's such a great, intuitive name for this cosmic shortcut. But look, a tunnel is pretty useless if it's just a one-way trip to nowhere. You need an entrance and you need an exit. So the theory goes that the entrance would be a black hole, using that insane gravity to rip open a doorway in space-time. But if the other end was also a black hole, well, you'd just be trapped. So you need an opposite, a theoretical and frankly super weird object called a white hole, something that violently pushes everything out, creating a one-way exit ramp. Okay, this all sounds absolutely incredible, like something straight out of science fiction. But it leads us to the million-dollar question, right? Are wormholes and these bizarre white hole exits just elegant math on a blackboard? Or could they actually be out there, for real, somewhere in the cosmos? White holes, in particular, are super controversial. I mean, the biggest argument against them is that they seem to break a fundamental law of physics, the second law of thermodynamics. But on the flip side, they might actually solve some other big cosmic puzzles. There was even this weird gamma ray burst back in 2006 that, well, some people thought looked a lot like a white hole. The jury is definitely still out on that one. And what's so amazing is seeing how this idea has grown over the last 100 years or so. I mean, it started as pure math on a page in 1915. It got its cool name in 1957. And then, get this, a full century after Einstein's paper, scientists actually managed to create a version of one in a lab. Now, let's be super clear. They didn't build a wormhole for spaceships to fly through. What they did do, which is still amazing, is they created a tunnel that could transfer a magnetic field from one spot to another, all while being magnetically invisible. So they basically made a magnetic field take a shortcut. This proved that the core principle, the idea of a tunnel through a field, could actually work, at least in a different branch of physics. And you know what? Wormholes aren't even the only potential cosmic shortcut hiding in Einstein's equations. There's another mind-blowing solution called the Alcubierre drive. It's this theoretical engine that doesn't break the speed of light, but instead it bends space-time around the ship. It would scrunch up space in the front and expand it in the back, letting the ship basically ride a wave of space-time to its destination. How cool is that? So, from pure math scribbled on a page to actual experiments in a lab, this whole idea of a cosmic shortcut just keeps evolving. Look, we're still light years away from actually navigating an Einstein-Rosen bridge, but the science shows us it might not be pure fantasy forever. And that leaves us with one thrilling question to ponder. Will these incredible theories one day become humanity's actual highway to the stars?